Hello everyone, welcome back to my next tutorial. In this tutorial we are going to solve this plate with 3 volts using code aster. So the dimensions are given here and the load is 1000 Newton has to be applied in this surface. This is we can solve in different way using a plane stress model, using a cell element, using a 3D element. In different way we can do it. In this case I am going to use 3D element. Now just open salome meca. Go to geometry. First we'll model geometry in salome geometry model. First we'll start from this line, this point. This is in its source. We'll do it in meters. Go to new entity, basic 2D sketch. Just observe it, apply it relative. Take it out this coordinate. Now we'll draw one by one. This line is 100 mm, that means 0.1 meter. 0.1. Go to fit screen, just apply. Height is 0.06. Just apply, and again we need to return back 0 minus 0.1. just apply it. Just sketch closer, it will close the sketch. So this is the rectangle we need to create. Next what we want to, we need to make a circle, 3 circles in the distance of 25, 25, 25. First we'll make a point or vertex. X value is 0.025 and Y value is 0.03. Just apply. This is to make it 0.05. just apply. 0.075. just apply, just close it. So 3 points we have created. Now we just want to make whole circle. Go to circle, select the first point, normal to OZ. Radius of the circle is 10 mm, 0.01. just apply. Second vertices, just apply. Third vertices, vertex 3, just apply and close. These 3 volts we have to create. Now we'll build a face to this model. Select circle 1, circle 2, circle 3 and first sketch. Go to new entity, build face. Actually this is our model. Now we have created. Now we need to provide the thickness. Before that I'm just saving this file. Go to new entity, generation, extrusion. Normal is OZ. Thickness is 0.1. Thickness is 0.1. We'll check how much thickness is coming. Oh, actually 0.01. Yes, thickness is 0.01. just apply and close. Now we have done of creating a geometry model. Now we'll create groups to apply the boundary conditions. Select this face, add, fix, apply. Similarly, just rotate your object, select this face, add force. Just apply, just close it. Now we have created two groups. So here we just want to fix it. Here we need to apply a 1000 Newton force. Now just go to geometry into mesh model. Just go to mesh, create mesh. Choose NetGen 1D, 2D, 3D. Similarly, you choose NetGen 3D parameter. Here just put 1 0. Here one more 0. Make it fine. OK, apply and close. Right click, just compute it. So this is the mesh we have generated. What we will do, we will make little finer. Edit. Very fine. Just OK, apply and close. Now this mesh is enough for our model. Now we'll save this. Now check the groups here. Here we need to fix it. Here we need to apply the force. Simply just go to code aster. Say OK. Now we will use a wizard to create the setup, linear elasticity. Next, next, next. Leave this material property. One side we need to fix it. Apply the fixed group 0 and 0. Here we need to apply the pressure. Actually we need to apply force. Just give some value 1. I'm just giving. Go to pictures, code aster. So .rmad, finish. Now go to the setup again. Everything is okay. Now we need to change this pressure value into force value. Press ref, just edit it. Just untick it. Cancel, cancel, untick it. Now we can go for force on the face. Just edit. Group of element is force. Pressure should be, this value has to be applied in x direction, fx. Actually this group also apply as a pressure only. The surface force value we need to do. This will apply as a pressure. So we need to convert this into a pressure. Force of 1000 Newton. So 1000 close. Close it. Here we need to name it as a force. Expression is 1000 divided by area. Area is 0.01 into 0.06. So this is the value of 1000 Newton force in this space. Just apply it, close it. Just OK. Just apply. The command is changed into force. Just save OK. Now we have modified the boundary conditions. Now what this static solver only calculate the displacement. We need to see the stress value also. Go to post processing, call champ, use the same value, sigma element and sigma node, criteria also equivalent element and equivalent node. Just apply it, save OK. Go to output. Here also just change into tut-55 as yes, change this result into call champ, save OK, apply, just save OK. Now we have done of creating setup. Now we can solve this file. Go to history view, just make it plus 5 seconds, just run it. This is actually a simple linear static analysis. It will not take much time, it seems. Just wait for a while. Mostly we will get a convergence issue in static nonlinear solver and dynamic nonlinear solver. Now it is solved without any error. Now we can check it here. Yes. Now we'll go for paraviews to do the post processing. Only thing is we need to check with the displacement as well as stress and which location it's coming. Pictures, code aster. Our file is result.rmd. Just apply it. Now we just want to see the displacement. Go to displacement x. The maximum displacement is coming on 1.2 e per 6 is very minimum x direction because we are applying in x direction. Now we can check how it is getting deforming. Yes, this is the way it's going to deform. We are just pulling out. Now we can go for equivalent stress, von Mises stress. Due to the holes, the stress is coming very high. It's coming around 4.9 e per 6. Actually we are applying the pressure of, here just go to code aster, plate with cut. Here we can check it. So that is the value we are applying actually. So the maximum stress is coming here. In 3 volt, the first hole is getting maximum stress. The remaining 2 volts are very less stress. Here you can see. The first hole is getting higher stress. Remaining hole are getting lower stress than the first hole. We can animate this also. Here number of frames are there. Yes. For static analysis only it's coming the number of frames. I'm just giving 25 frames. Just say OK. Now we can do animation. Loop. So this is the way we can check it. Actually we are solving in single step. For viewing purpose only we are doing this animation. So this is the maximum stress. It's coming around 4.9 megapascal. We can change this into this also. So in that we have completed this tutorial. Thank you for watching my video. Please subscribe my channel for more videos. Thank you.